Hello everybody, I'm Adam. In this problem, we're going to be finding the equation of a plane that passes through a given point with coordinates 1, 3, and -7, and is perpendicular to the vector n equal to the unit vector j. So, to get started, let's take a look at what the standard form of an equation of a plane is. So we have a standard form and a general form, which we'll take a look at a little bit later. So the standard form of the equation of a plane looks something like a times the quantity x minus x1 plus b times the quantity y minus y1 plus c times the quantity z minus z1, and that is all equal to 0. So what is this? Well, if we take a look at this, so the a's, b's, and c's are the components of a normal vector, call it n, and by normal vector we mean vector perpendicular to the plane. And then we have our x1, y1, z1. What those are coordinates of a point that lies on the plane. So we'll call that point, say, P, with coordinates x1, y1, and z1. So those are what we need to satisfy this equation or to plug in and find it. And that's exactly what we're given. So taking a look at what we have, so from our point, here's our x1, y1, and z1. And for our normal vector or perpendicular vector, we have our unit vector with components 0, 1, and 0. So that gives us our a, b, and c. So with this, we can go ahead and plug everything in. So into our standard form, okay, so a, we're going to have 0 times the quantity x minus x1, which is 1, and then plus b times y minus y1, b is 1 times y minus y1, which is 3, and plus c times z minus z1, or 0 times z minus -7. Right. And so we can simplify this. 0 times x minus 1, well, that's just 0, and 0 times z plus 7, that's just 0. And whoops, let's of course set our equation equal to 0, which we need. So then what we're left with is 1 times y minus 3, which leaves us with just y minus 3 equals to 0. So our equation simplifies to this. Now, this equation actually is in general form. Now, the directions didn't specify which form to find it in, but it's good to recognize the difference between the two. So this is in general form, where our general form looks like a times x plus b times y plus c times z plus d equals to 0, where our a, b's, and c's are the components of our normal vector, d is just some constant, and of course this is set equal to 0. So we don't have x's or z's, but we see that this satisfies the general form of the equation. So we're pretty much done. A good practice, though, before we leave is to make sure that the point that's supposed to be going through your plane satisfies this equation. So if we look at our coordinates, well, we don't have x or z, but for y equal to 3, if we plug that in, 3 minus 3 does give us 0. So we have a correct equation. So thank you very much.